connect memory card reader to the PC. And then put it inside your laptop or PC. Format it first, right? Just go to this and format the memory card. I know it's a new memory card, but still format, right? And then open the second software disk imager that you have installed. This is what the UI you will notice once you open it. And then you will select the image file. What is the image file? This is the image file. Once you download this, you will see an ISO file, right? And that is the image file. So you will select that. It will be in your downloads folder, and you will select the memory card, and then you will just say write. You click on this, it will start formatting the image, this image on this memory card. It is going to make your memory card a operating system disk type image or operating system memory card type. So once it is done, your memory card will be ready. Okay. Select the downloaded in step 1. Select the file downloaded in step 1. That is basically this file that you downloaded in step 1. And format the memory card, right? So that gives you the operating system inside a memory card. After you're done with it, just take that memory card, put it inside your Raspberry Pi, right? And then you need to supply the power here, right? Connect your micro USB cable over here, right? And connect your keyboard and mouse. The monitor that you have, HDMI cable, use HDMI cable to connect your monitor. And after you connect your monitor, so first thing is you connect your monitor, you connect your keyboard, mouse, and the next thing that you do is you power. So power should be the last thing that you do. So after you connected everything, you power it up, and you will notice this particular UI that comes on your TV or monitor or wherever you're, right? This is the UI that you will see. So it's an entire operating system that you will notice where you can write your programs and you'll be able to do a lot of things. Now, once you do this, now obviously you don't want to keep it connected to your TV, right? Because there are people watching TV in your house all the time, or people using another monitor all the time, or a PC monitor. So I want to be able to view this on my laptop, right? Whatever desktop interface of my Raspberry Pi is coming on the Pi, I want it on my laptop, right? So if I want to do that, I can take a remote access of the desktop view, remote access of the desktop view of my Raspberry Pi. So whatever is available on my Raspberry Pi desktop view, I can get a remote access to it, right? And for that, so once I use this VM, connect it to a monitor or do some monitor or display, I can get that monitor interface on my laptop itself. Right? That way I'll be able to directly see whatever is happening. Let me show you what happens when you do that. So you install VNC on the desktop, you enable VNC on your Raspberry Pi, and then you open VNC and connect Pi finally. Okay. So notice this. Just keep it. Okay. Let me just open that camera one more time. So this is my Pi, like you can see here. On top of it, there is a small shield. I'll talk about that, which is currently connected to this display. Okay, but it's not that I have to keep it connected to this display. So if I want, I can take that access on my laptop. So check it out how I'm going to take that access on my laptop. So I'll just minimize this. I'll open my VNC and I will type in the IP address. This is the one-time thing. That is where you will need the IP address of your Pi. Note the private IP address of your Pi. So how do you note that? Once you have connected to your monitor, once you have connected to your TV, right? When you're able to get the display on your TV, at that point, what you should do is you should go to your TV or monitor, right? And you just take your cursor on the top right corner. I know that it might not be visible to you clearly, but a small window pops up. Notice I take my cursor away and I take it again. There's a Wi-Fi symbol. And if I take my cursor there, it shows me the IP address. Right, I'm able to see my IP address. Now, once you have installed VNC and you have set it up, all you need to do is do a VNC to that IP address. So 101 was my IP address, and I just go to this software and I hit. It asks me for password. I hit my password, and you can see that my UI access of my Raspberry Pi, whatever is happening on the actual display here, you can see this is the actual display, and the same thing I'm able to notice here, right? That is basically on my uh, machine, right? So I can directly take a remote connection. So remote connection is what we use whenever we want to further connect to that we can connect to it directly. Okay. So I would like to show a little bit of a demo here, just a couple of things. This is my Python. I've logged in, and I can open the editor. I can start writing my Python program from here, right? I have like this comes installed, pre-installed, right? This IDE and all comes pre-installed. I can start programming directly, or I can just take a look at this. Let's say something like Python is an interpreted language, so I'm currently running on an interpreter mode, and you can see that it works just fine, right? Whatever I do, it does. So I can run Python programs easily inside this, and I have libraries that are available for me, right? Libraries that I can readily use for various other purposes. Now, one of the things that is available as a part of Raspberry Pi along with the Raspberry Pi. So we understood that we can connect it to different sensors and motors and things like that. One of the major capability of Raspberry Pi and why you would want to use Raspberry Pi is the shields that they provide you, right? If you want to control various things, for example, what you're seeing here are few shields that are readily available in the market. I can directly use these shields and I can take information about, for example, this is a re-speaker. So, if you have seen the movie Iron Man and you have seen that Iron Man or Tony Stark, I mean, of course you have, right? And Tony Stark talks to Jarvis all the time. So how is Jarvis able to hear him no matter where he is? So re-speaker can give you that kind of capability. It has a very good range, within a range of 4 meters. Even you might be making a minutest sound, this will capture it. Right, so that is how efficient this particular mic array is, because it does not have a single mic. It has up to 16 mics sometimes, right? So more the number of mics, more the power, and some re-speaker come up with their external power supply as well, right? Which give you even more added range. So if you want to build yourself a Jarvis going forward at some point, and you want to give voice commands, and you want the devices to be able to hear you from wherever you are, this is the key for you. So Amazon Alexa or Google Home, they all use some or the other kind of re-speaker, and we have such a re-speaker module available for Raspberry Pi as well. If I want to use this, all I have to do is buy one of this and put it on top of my Raspberry Pi. So these pins that you are seeing here and these pins that you are seeing here below they connect directly to the Raspberry Pi's GPIO pins, right? And they provide me with a library through which I can take control over it. So there are these shields that are available and that allow me to do it. Similarly, I have one shield on me right now. This is called as sensor, and this is the sensor that I currently have. This is the shield that I currently have as well. Let me just show it to you what it looks like, and I'll be talking about a few things that you can do with this particular board as a sensor. Okay, and I also have a couple of use cases I'll be talking about. But before that, take a look at this. The camera is disconnected. Sorry about that. Just turn my band. So you can see my Raspberry Pi has the shield sitting right on top of it. So for example, I can just take the shield off. I just hope it does not turn off my Pi. It's in a very delicate situation. So I have just removed this, right? This is my shield that I have here, and it sits right on top of this. And if you'll notice, I also have a So Raspberry Pi is also connected to a camera, right? So what you are seeing here is a camera module. I'll be running this as well, and you can see how it is connected to this little slot that is provided here, right? This slot. And I'm also placing my shield on top of it so that I can experiment a little bit on this shield as well. So these are the couple of things that I have. You can see it shines so brightly right now because I just plugged it in. It's a normal behavior of it. And then it goes offline. Okay. So what I will do is I'll just give it a minute. In fact, what I will do is I'll just go ahead and reboot my Pi, and then I'll start with the demonstration. I guess it just got disconnected. That's a good thing. So once it reconnects, I'm going to be showing you a couple of things that we'll be looking into. Okay. Now let's proceed with this. Capability. 3D gesture tracking, you can just move your hand on top of it and you can identify the pattern that you are making, or a relay shield. Using relay shield, you can connect this relay shield to something like a light or a motor. It could be the water pump in your house. It could be anything else that is taking a higher load, right? You can connect it to it and you can place the shield on top of your Raspberry Pi. So there are different shields like this. I'm just showing you three, and I think there are somewhere around at least there are around 40 to 50 very commonly used shields for different purposes, and there are a lot of other hundreds of different open source shields that people are working on all the time, right? It gives you a different kind of capability. For example, I have a HD camera shield, right? And I have a microscope shield, by the way. Microscope shield, right? That can connect to this. So there are different type of shields that are available in the market for this device. Now, again, I'm specifically talking about one of the shields, and this shield is called as Sense Hat, wherein this is what it looks like. It has a temperature sensor, humidity sensor, and all of that. And I can just install the library by running this command. Again, library, the key, you know the drill. So once you run this library, you have all the modules that are required already installed. The library is installed, and then you just import it and then just start running it to get the output of it. Okay, so let me just I'll just show this at the end. Once we are done with the part, I'll be showing this couple of things. Just getting the temperature value from this, as well as how you can display message. And I'll be talking also about a little bit about emulator if time permits. And then I have a camera module, and I have provided you a link through which you can get started with this little demo that I'm going to show you, right? And a couple of use cases. So let me show you this demo at the end. Let's just finish with the use cases, and then we'll come back to the demos. One of the use cases that I was working for one of the company, in fact, the NDA is no longer in place, so I can kind of disclose the name of the company. So we were working on this project for Bosch, right? And what we were doing is we were collecting the data that was coming from our car, and we were continuously monitoring it. Okay. Now, if you have bought a car after 2009, you'll be having a OBD adapter. Okay. Within your car, you will find this little plug to which you can connect this OBD adapter. You can buy it from Amazon at around 230, 250 rupees. It's called as OBD2 adapter, OBD2. Okay. And this has, it has an inbuilt Bluetooth chip as well as Wi-Fi chip. What this does is, see, your car is doing the games here. Okay. Your car is the device that has all the sensors. Okay. So your car has all the sensors, and this connects, and all car sensors are connected to the ODP plug. OBD plug, this plug, right? This is just an interface. What you are seeing here is just an interface through which I can pull all that sensors data, right? So what we were doing is we were pulling that data continuously from our OBD adapter, right? And we had connected various other things for identification of the person who was driving the car. We had microphone to see the live streaming that was coming from car's camera. We had a camera setup, right? We had Azure speech recognition put in place to identify. So again, it was connected to a Raspberry Pi camera, right? And a Raspberry Pi mic, right? So Raspberry Pi mic, and it would identify, listen to the speaker and identify who's the person who is talking. And then the OBD adapter itself, that would pull the data from my car sensors. Right? And then I had a few other things, accelerometer, GPS, compass, and other things that I had built within this device. So we were continuously capturing all that data and we were streaming it. Okay. And we had a Power BI dashboard. So it is actually a dashboard by Microsoft where I can just display all of that data that is coming in directly. Right. And then we use a couple of services like Azure IoT Hub and Stream Analytics Job. Now, these are cloud specific services, so I am not going to emphasize much on them, but just understand that these are the services through which I can actually ingest that data and send it to my SQL database or some kind of a database, or if I want to save it for some purpose, or if I want to process it for some purpose, I can use one of these services. And how are they connecting it? Using Wi-Fi, right? We use 4G modem. 4G modem through which it was connecting to the IoT hub and sending all the data. So we are using one simple use case of this one. And then think of it as another use case, motion surveillance, okay? And why would you want to use Raspberry Pi here? See, let's say that you are continuously streaming data, right? It would take a lot of amount in database if you are continuously saving the entire 24-hour footage. But we know that in a place like a ornament store or something like that, I know we are running out of time. Just bear with me for another 5 minutes. We're almost done, okay? 24 hours of video is not required. Maybe 2 to 3 hours of video, right? 2 to 3 hours of video within 24 hours of video is actually significant for me, because that is where some kind of motion is actually happening. If it is an ornament store, right, it's not that 24/7 people will be there. Okay, only when there is some kind of motion that is happening in that ornament store, that is when I want to save that video. Otherwise, I simply want to discard that video, because saving all 24 hours of video to cloud, or sending all 24 hours of video to cloud and then saving it there, it includes a lot of cost. It includes the bandwidth cost, because you are using 24 GB, let's say, for every hour 1 GB of video is getting ready. So you are uploading 24 GB of data, that bandwidth cost is applied, and saving 24 GBs every day on these systems, right? That is also a considerable cost. So what I will do is, I'll use my Raspberry Pi as edge device. This is a different type of use case, okay? So I'll use my Raspberry Pi as edge device. What it does is, here my Raspberry Pi does pre-processing for me. It is continuously taking the video and using a library called as Motion. So this is a library. I have provided a link here. It would be great if you can go and take a look at this. If you go to this library, you can just run a command and connect a camera to it, and the Raspberry Pi will start saving the video only and only if there is some kind of a motion, right? And it will start pushing only those videos to the cloud. So end of the day, what you're doing is, out of your entire 24 hours of video, you're only extracting 2-3 hours of most important part of the video and sending it to cloud. So first of all, the bandwidth cost is reduced almost to more than 10%. Bandwidth cost is reduced to 10%. Earlier it was costing you so much, and now it has reduced to 10% of what it was costing you earlier. And even the storage cost has got down to 10%, right? So that way, it is better to use my Raspberry Pi at the edge. See, if I wanted, I could have simply sent all the data to cloud, all 24 hours of video to cloud. But did I do that? No. I did some smart work here. I used this device as an edge device, and I then did a little bit of pre-processing here before sending it to cloud. That is what edge device does. It does pre-processing. What else edge device also do is, sometimes local control, right? Just want to control something from one endpoint to another endpoint. I can use edge device to do that. This is a different use case of oil rig. Excuse me. So all of these oil rigs, have their own set of sensors, giving information about the amount of oil that they are pumping and all other information like the motor health and all the other things, right? And they are all using a microcontroller through which it is connected to different sensors, and they are sensing it, right? And for communication purpose, instead of using Bluetooth or Wi-Fi or anything else, I am using, in this case, Zigbee modules. Zigbee are also communication modules that work using radio frequency. They also work with typical 2.4 gigahertz. They have a range of 100 meters. But the best part about these is, if I have 5 Zigbee modules like this, right? And let's say this is my source. I'm standing here, okay? And this is when I want to send the data. When I send the data to this particular Zigbee, right? Even though I have a Zigbee module on me, I have a microcontroller. This is the microcontroller I want to send that data to. Is connected to Zigbee. Even though the distance is too far, okay, let's say that this is somewhere around half a kilometer, right? We said that half a kilometer. We said that the Zigbee range is 100 meters. What Zigbee magically does is, it uses these intermediate Zigbee modules to send the data. So instead of sending it directly here, it sends the data to here, and then it sends it to here, here, and finally it reaches the destination. So Zigbee allows you to create mesh network, right? Allow you to create mesh network. So you might be running into various scenarios where you have hundreds of devices that are kept on 100-meter or 200-meter proximity distance, and you want all of them to communicate with each other, right, effectively. And you also want a central Raspberry Pi edge device. So this is your central Raspberry Pi edge device, right? You want this to be able to understand final information that is coming from all the sensors. So what happens is all of these sensors connected to microcontroller and Zigbee keep sending the information, and finally it reaches the Raspberry Pi, right? And your data might be going through several intermediate jumps before it reaches Raspberry Pi. So that is one more module where commonly used in oil rig. So all of these microcontrollers connected to these XP modules are sending the data, and finally there is one central Raspberry Pi sitting in a control room that is actually getting the final data that is coming here, that way also connecting to all the intermediate devices. So this is ideally a network of devices if you want to build, just like we have network of computers, right? What does computer network use? A border gateway protocol, right? A gateway protocol works in a similar way. Whenever you are sending request to facebook.com, understand that before your request reaches to a facebook.com server, it is going through your neighbor's router as well, right? Because that is BGP. And similarly, it uses this mesh network topology, also similar characteristic. And then we have a smart house automation example wherein you can just you can use MQTT when it comes to global connectivity, right? Whenever it comes to talking to internet, use MQTT protocol, right? And when you say MQTT publish AC control, this is the topic to which you are submitting something, right? And so basically what happens is you get an MQTT server. You can create an MQTT server on cloud. Okay, there are different providers like Cloud MQTT, Azure IoT Hub, AWS IoT Core, like that. There are different providers that are available. I'll be showing you this in a minute. There are different providers, and I can go and create my MQTT with them. For example, that's the end of my slide deck, by the way. Now I can go to Cloud MQTT. Check this out. And here I can set up my MQTT publish subscribe MQTT broker. Okay. Once I set up this MQTT broker, right, it is like I'm setting up an endpoint on the internet, and I can talk to this endpoint from devices. If I have 10 devices, those devices can talk to each other via this endpoint. Okay. So what that means is this is how MQTT is working here. Okay. So I have set up a MQTT broker, right? And I have devices connected to it. Okay, this is my Raspberry Pi. And then I have also created a Cloud MQTT. This is on the internet, right? Now what Raspberry Pi will do is it will keep publishing, right? And then I can have another device that is subscribing. What are they going to publish and subscribe to? To a topic, right? So it's a pub-sub model of exchanging messages via internet. Okay, so how do you do that? If you just have Wi-Fi connectivity, you can do it, no problem. You choose to go for a Wi-Fi shield with Arduino if you want. You can go for a ESP8266 if you want. You can go for a ESP32 if you want, different chips, development boards, or if you want, you can also go for Node MCU or Raspberry Pi, which already has a Wi-Fi connectivity on them. So you can then go ahead and publish and subscribe, right? And publishing and subscribing is as simple as this, friends. Right? Just say MQTT publish to send a message. This is the topic, AC control. And then your Raspberry Pi is continuously listening to topic. And this is how you write the code to connect to this. If you'll notice, once I created my Cloud MQTT endpoint, it gives me a server name, username, password, port number. This is all I need, right? This is all I need. And then I specify that in my code, right? And then I establish a connection client. Either way, even in Python, even in C, it's very similar. Syntax may change a little bit, but it's very similar to this, right? and then your mobile is publishing a control, and the message in this case can be something like on or off, right? And then that message is being that topic to which your mobile is publishing, that topic is continuously subscribed by this Pi, right? So all the topics for all of these control is subscribed by your Pi. So the moment there's a message coming in, this is the subscribe code, this piece of code that you are seeing here on the right side. The moment it is doing this, it is subscribing for that channel. It has also done the previous part. It has used the username, password, and that. And finally, it has subscribed. The moment it gets a message called as on, then it can turn on one of the digital pins here. And when that digital pin turns on, it is going to turn on a relay, and then relay is going to actually turn on your AC. So that is how you finally architect the things. Now there are a couple of programs. One program that I want to show you, wherein I'm just using my Raspberry Pi camera to get my video display on my laptop. So I can actually use this Raspberry Pi camera anywhere in my house. So I can just keep it anywhere in my house, and I can just browse the video feed coming from my camera, right? So I've already installed the library. I already created the program. I'll just show you the program. Second, let's see what the name of the program was. Okay, that was the name of my program. Python 3 I might have to use, and I'm running this program right now. What this is going to do is, it is going to start running the camera feed on my browser. Check this out. Currently, I'm just opening the browser of my Raspberry Pi. So this is the UI of my Raspberry Pi, like you already know. And I'm just trying to open the browser, right? And I type localhost 8000. It starts displaying me whatever is happening on the camera, right? And there is a little delay, but you can notice that as I swing my camera, whatever is happening. So this is, where is this display happening? This display currently it is happening on my Raspberry Pi, right? So if you want, I can turn my camera towards my Pi's display, and you will notice that, okay. So the same thing is being displayed even on my Pi because it is the same camera feed. So this is coming from my Raspberry Pi camera, right? But that is not interesting. What is interesting is that, so this is coming from my camera, and I'm currently seeing it locally inside the Raspberry Pi by typing localhost, right? And it is working perfectly fine. This is the camera feed, and you can see the rotating there. Now what I will do is, I'll go to my laptop. So this is my laptop, as you're seeing in the display right now. And this is not on my Raspberry Pi. I'll just open the browser, and I'll hit the IP address of my Raspberry Pi, 192.168. Let me see what is the address of my Pi. I think it is, if I take the cursor here, you will notice it gives me an IP address. So I have two adapters of Wi-Fi connected to my Pi right now. So the reason why I have two Wi-Fi plug is because I get added layer of internet, right? Added bandwidth, which helps me sometimes. So these are two IP addresses. I just click one of the IP address, and I will start seeing that camera feed on my laptop as well, right? So currently the feed that you're seeing, it is coming from my Raspberry Pi, right? And you're seeing that it is being shown on my laptop, right? It is showing it on my laptop. So how did we do that? That little program that I ran, perhaps I have already provided the documentation for that, and it is providing you with the camera output of that Pi, right, on your browser. So basically, you can keep this Pi anywhere in your home, maybe at your door, maybe at your window, and then you can turn on the camera, and you can just go to that IP address and start going to that IP address, and you will start seeing the feed of whatever camera feed is coming into your Raspberry Pi by just going to that IP address. So this can be used for various different type of purposes. For example, taking a global remote and monitoring the remote globally. I can enable something called as port forwarding to do that, right? Another last demo that I want to show you is getting the value out of my Sensat, right? How do I do that? So let me just show you a very simple example. This is my Raspberry Pi, and let me just, camera feed is still running, so I'll just close that camera feed. There is a slight delay, actually. Okay, so that was the program that was running, and we were able to see that live camera feed. coming on my laptop as well from the browser. I was able to access it via browser. Okay. Um, there seems to be some problem with my house router. I'm not able to kind of control anything on my Raspberry Pi view. Let me just try doing the RDP one more time. If it doesn't work, then I think I'm gonna have to just talk about the code here. So there seems to be, so actually my room is slightly far away from the router, right? Which causes a little bit of problem sometimes. Usually it doesn't happen, but ironically today it is. Anyways, so what I was planning to do is I was just planning to show you a couple of things. I just wanted to show you that how I'll be running these pieces of code and I'll be able to get just these 3 lines of code, right? And it starts giving me the temperature value. The moment I run this command, first I run this command in Python, then sensat, then this, it gives me temperature. If I'll just say show message hello world, again, this is the library function that I'm calling and it will display hello world message here, right? So that was the example that I have here. Just going to display that. So majorly it is used for edge computing and edge is where you use it. I just want you to have that thing in your mind. Otherwise, there are various other use cases as well where you use, right? But otherwise, understanding where you want to use it, how you want to use it becomes important. And like I said, edge is where you typically use these kind of boards, right? So from this webinar perspective, that's pretty much what I wanted to discuss and I wanted to show you. Let me spend a moment here seeing if you have any questions, taking up any questions that you have. Okay, sure. Thank you. How is industrial IoT, Mahima? It's about the devices, it's about the right components, it's about picking the right communication protocols and right sensors, right? That is how I would define it. But workflow, everything else is same. Only thing is you're going to be working with a different kind of hardware, different kind of sensor, different kind of everything else. Good steps to become cloud architect. Ankita, start working on it, start doing as many things as possible, stay curious all the time, stay creative all the time. Think of a use case and just start working on it and building things, right? At this point, this is something that I would recommend highly. Just keep exploring. If you have the zeal of doing things, you will eventually do research, you will look at some YouTube videos that will fantasize you and you try to do more and more. That's how you keep working around that. More frequency, more the speed of information transfer. Is it because we generally use frequency modulation? Kind of, Ramika. So thing is more the frequency because what happens is more the frequency meaning what? More number of cycles per second. How is your data traveling? Your data is traveling in cycles, right? Every single cycle is representing either a 1 or 0. So more frequency meaning more number of cycles, more number of cycles meaning more data transfer. That is how the speed is more. So yeah, frequency modulation and things like that are a different aspect to it. But yes, they are definitely a part of it. Cloud storage in some projects instead can be use our own storage device and any licensing. Of course, Prathamesh, you can use your own devices as well. But cloud services, honestly speaking, has got very cheap these days. You can set up a virtual machine and you can store TBs of data, terabytes of data, and spend just 100 or 200 rupees per month as well. So we have cloud offerings like that. But if you want to do it locally for some reason, you can still do it. You can use your own Raspberry Pi. You can use port forwarding within your router to send all the device information to your Raspberry Pi. That is no problem. Licensing wise also, no one can save anything because you're doing it for yourselves. That is no problem. So Mahima, like I said, Zigbee is actually a device, okay? I mean XB, my bad, sorry. The device, XB is the name of the device, and Zigbee is the protocol that has built for the device. Now, one of the interesting things about Zigbee is that it comes with a library called as cluster library or Zigbee cluster library, commonly referred as ZCI. So when the Zigbee was initially built, Zigbee is an older thing. Right? So when the Zigbee was initially built, it was specifically built for end user products like doorknobs, light bulbs, automatic windows, car doors, garage doors, and things like that. So what a Zigbee cluster library provides is Zigbee cluster library provides you with the functions specifically written to control those devices like door lock, bell, devices like your door. So it has function calls to perform those. So most typically, if you are using Zigbee, you are also having a Zigbee type device on the other side, right? So it has door lock module. For example, just take a look at this. So Zigbee was one of the initial protocols when IoT was getting on the fledge, right? And that is the reason many people started manufacturing devices like door locks, which has embedded Zigbee with them. So if I want to control this module, right, I don't need to buy another XB module with the Arduino board. There's already a microcontroller, already a Zigbee module in it. I just need another Zigbee through which I can send a ZCI command. That is Zigbee Cluster Library command. And using that command, I can directly control this. So that is how Zigbee is in the market as of today. So, right, that is the thing about that. Now, I think that's pretty much it that we have. Um, what about heating issue that might face small chip processor? Yes, and you get heat sink for Raspberry Pi. So if you are doing some kind of an intensive compute, consider using heat sink for Raspberry Pi. Right, these are going to cool down your processor to a considerable extent. You can just stick it on top of your Pi, and it will be done. So I think those are the questions that we have. I hope this session made sense to you all. And I hope you had at least some kind of a takeaway from this, even if you had some experience or without experience. Rutvik, again, just go with libraries. Just go with the libraries. If you have any concerns, if you need any extra help, you can get in touch with Srinivas sir, and I can help you, provide you with links to enable and do something. If you are specifically looking for something, I can help you out with that. So with that note, thank you everyone for your attention. Thank you everyone for hearing me. I had a great time having this session. I hope you also had some learning done. Over to you, Srinivas.